is filled up by liquids. So this will be row 3. This will be row 2. Row 1. And this is row 1. Find there's unknown liquid row 3. So you have to find out the density of the liquid row 3 in terms of row 1, row 2. And H1, H2, H3 are given. Find a relationship between densities better. Heights are given for us like this. Vertical tube it is. Vertical tube filled with different liquids. So what is the core idea? Again, the pressure, it's a static liquid. The pressure at A should be equal to the pressure at B. I think I'm giving color at least. Looking at this color, please do identify. It need not be perfect circle. Come out of that perfect geometrical shape. That is most irrelevant here. If you're able to construct, okay. If you're able to construct the perfect geometrical shape of tube, okay, now you can say something like this. Okay, we can manage still. So even any deformations are there in the tube can be managed. I think only when you go to the lab, you'll understand all these conditions. Because on paper, how much will fight it? Come for this one. So pressure at A must be vertical tube filled with different liquids at equilibrium. No, pressure at A must be equal to pressure at B. Pressure at A on the left hand side should be equal to rho 1 GH1 plus rho 2 GH2. Should be equal to this one, rho 3 GH3 plus rho 1 G. We don't know this. This should be equal to how much? H1 plus H2 minus H3. What we want the rho 3 is unknown. So simplifying that, rho 1 H1 plus rho 2 H2 minus rho 1 H1 plus H2 minus H3 by so rho 1 H1 gets eliminated here. So this will become rho 2 H2 minus rho 1 H2 plus rho 1 H3 by H3 equal to rho 3. Okay, like this we can manage the density of the unknown liquid. Need not be perfect circular. That's what you mean to say. It need not be always some, even if any deformations. Are you seeing that one? Just I brought some deformation here. Okay, doesn't matter. We can manage. So it need not be perfect bore. So we usually say, don't say area of correction, we say bore. The bore need not be uniform. Even if it's a non-uniform bore, okay, the problem is still valid. So they may test you in more than one option. If the bore of this vertical circular tube is non-uniform still, will this be justified? Yes, answer. So this answer is independent of the bore of that particular thing. Provided what when the volume, both the liquids have equal volume. The condition should be satisfied.
Sir,
Yes.
Sir, for this question, I got tan theta is rho 2 minus rho 1 by rho 1 plus rho 2, sir.
Rho 2 minus rho 1, huh?
Sir.
Okay, that one, yeah. Nobody replied. Because rho 2 will be denser. Yeah. Okay, let's take one more, last.